In this video, we're going to introduce three more trig identities and then how we can use these to solve trig equations. So, first thing what we already know, we know tan theta is sine theta divided by cos theta. We also know sine squared plus cos squared equals 1. And then because of this first one, that tan theta is equal to sine theta over cos theta, that means tan squared theta would be sine squared over cos squared. Now, from these, we can get two more identities. So 1 plus cot squared is equal to cosec squared, and then tan squared theta plus 1 equals sec squared. Now, we need to be able to prove these in an exam, so we're going to look at the proofs of these now. Okay, for both of these, we start with your original equation that we know, the original identity, which was sine squared theta plus cos squared theta equals 1. Now, what you're going to do for the first one is to get from this first line to the second line, you're going to divide through by sine squared theta. So that gives you sine squared theta all divided by sine squared theta plus cos squared theta all divided by sine squared theta is equal to 1 divided by sine squared theta. Okay, sine squared divided by sine squared is dead easy. It's just 1. And I'll come back to the second one. It's the hardest one. 1 over sine theta is cosec theta, so 1 over sine squared is cosec squared theta. And we should remember from up here, we were told that tan squared is sine squared over cos squared. So what this is, it's a reciprocal of that, cos squared over sine squared, so that means it's a reciprocal of tan squared. So that is the same as reciprocal of tan squared, remember, is cot squared theta, and that gives you your first equation. Okay, the other way you could do it, start with the same thing. We'll start with sine squared theta plus cos squared theta is equal to 1. And what we're going to do here is we're going to divide by cos squared theta. So if you divide by cos squared theta, you're going to get sine squared theta divided by cos squared theta plus cos squared theta over cos squared theta, and is equal to 1 over cos squared theta. We'll do the easy ones first. Oh, they're all easy here actually. So sine squared divided by cos squared we know is tan squared theta. Cos squared divided by cos squared is just 1, and 1 over cos theta is sec. So 1 over cos squared will be sec squared theta. Okay, if you get a question like this, folks, what I would do is I always write down. So if you get a question like it involves sine squared, cos squared, or cot squared, or cosec squared, or tan squared, or sec squared, I would start by writing down this equation, and then I would write these two equations down. So write this equation and this equation down. So as you'll see in the next example that I'm going to do. But you do need to be able to prove these. Very easy. Start with the original equation and either divide every term by sine squared to get this one, or start with the original equation and divide every term by cos squared to get this new equation. Okay, in this next example, it says solve 3 cosec squared plus 2 cot is equal to 4. So here, the first thing I would do is see if I've got a cosec squared and I've got a different trig function, I've got cot. So I've got to change this one. So I would start by writing down my sine squared theta plus cos squared theta equals 1. And I need to get cosec squared. Think about what cosec is. It's 1 over sine squared. So I'm dividing through by sine squared. Sine squared divided by sine squared is 1. Cos squared divided by sine squared is cot squared. And 1 divided by sine squared is cosec squared. So I rewrite my equation. And what I mean by this is I rewrite everywhere I see cosec squared, I'm going to rewrite it as 1 plus cot squared. So I'll go from here, I'll multiply out and tidy up. That's 3 plus 3 cot squared theta plus 2 cot theta is equal to 4. And then I will just write that, tidy up again. That's 3 cot squared plus 2 cot theta minus 1 equals 0. So my sum is equal to 2 and my product is equal to minus 3. So my two numbers are going to be, 3 and minus 1. So we can rewrite this as 3 cot squared theta plus 3 cot theta minus cot theta minus 1 is equal to 0. Pull a 3 cot outside a bracket, leaving you cot theta plus 1, and then pull a minus 1 outside a bracket, leaving you cot theta plus 1 equals 0. You've now got your common bracket, so you know you're on the right track. So just write down your common bracket, cot theta plus 1, and then you've got 3 cot theta minus 1 in your other brackets. Okay, I'll have to scroll down a wee bit here. So we're just going on to solve this. So the first put the first bracket equals 0 means cot theta is equal to minus 1. Second bracket equals 0 means cot theta is equal to a third. Okay, as I've said many times before, we don't have a cot function on our calculator, we have a tan function. So change these to tan. So how you've got from cot to tan is you've turned it upside down, or you find a reciprocal. So you do the same to the minus 1. The reciprocal of minus 1 is still minus 1. Likewise over here, reciprocal of cot theta to give you tan, reciprocal of third, you will get 3. So we're on to basic angles and just solving. Basic angle for this one is 45 degrees, and we'll just work that one out. I'm running out of space here. Yep. Okay, so C, A, S, and T. And my first tan is negative, and tan is negative in here and in here. Put your 45, put the angle always with the horizontal, remember, so 45. So my first angle is round to here, and my next angle is all the way round to here. So what have I got? I've got theta is equal to theta is equal to 135 or 315 degrees. For this one, my basic angle worked out to be 71.6 degrees. And tan was positive this time, so it's in here. And it's in here, so 71.6 degrees, I should say. And 71.6 degrees. So for this one, theta is equal to 71.6 degrees, and it's going to be 251.6 degrees. So your final answer, this is all over the place, apologies. My answer for theta smallest one is 71.6 degrees. The next one is 135 degrees. The next one is 251.6 degrees. And the last one is 315 degrees. Okay, for this one, they've been nice enough to us. It's all in terms of cosec, so we don't have anything to do here. The only problem is the angle is 2 theta, so we're just going to change that to be from the angle is 2 theta, so double the range, so that's 2 pi, and that's minus 2 pi. Okay, let's have a look and see. So we've got here, we will just bring everything to one side. We'll have cosec squared 2 theta minus cosec 2 theta minus 12 is equal to 0. And my number, that's an easy one to factorize. We'll just jump to it. I think that's going to be cosec 2 theta minus 4 upon cosec 2 theta plus 3 is equal to 0, which means cosec 2 theta equals 4, or cosec 2 theta equals minus 3. Okay, for this one, that means reciprocal of cosec to give you sine. So sine 2 theta is equal to reciprocal of 4 to give you a quarter, reciprocal the cosec to give you sine, and reciprocal of minus 3 to give you minus 1/3. Okay, we're into our basic angles. I've run out of space. I'm going to have to do these. I don't know, I'll do it here. I'll do this one here. Basic angle for this one is going to be, it's radians, remember, so it's 0.25 radians. And we'll squeeze this in here. C, A, S, and T. Okay. Now in this one, it's going from minus 2 pi to positive 2 pi. Do not mark anything on the axes. We'll just talk you through how we get you get your two things. So it's 2 theta first of all 2 theta is equal to, and we're going to have our values. So we're going to have loads of solutions here for this one, unfortunately. So I have to mark it in where it was positive. So it's going to be positive in here and in here. So that's 0.25 and 0.25. So the first one we're going to have is 0.25, and then pi minus 0.25, which is going to be 2.89. And then we're also going to, so that's going the positive way. We also are going to have the negative ones as well. So we're going to have all the way around to here. So it's going to be minus pi plus 0.25. So, or well, minus pi really minus another 0.25. So it's going to be minus 3 minus 3.39. And the other one is going to be minus 2 pi. And then, but you're not quite 2 pi, so it's plus 2.5, so it's going to be minus 6.03. Okay, and your final answer then is just divide those all by 2, so I'll just do a wee bit of calculator work then and write those in. Okay, so just divide all 4 of those answers in radians by 2. To 2 decimals for this is I've got 0.13 radians, 1.45 radians, minus 0.170 radians, and minus 3.02 radians. Okay, just got to do the other one then. So this is our this was our sine 2 theta is equal to a third. So I'll just write that one out again just to make it a wee bit clearer. Sine 2 theta is equal to minus 1/3. So I'll just sag this up here. It's a mess. But we'll say our basic angle then, if you do sine to the minus 1 of just positive 1/3, you will get 0.34. So do your diagram out, your cast diagram. Don't label the axes anything except for your CAST in the quadrants. Sine is negative, so it goes in here and in here. So is that right? Yep, it is indeed. So my sine's negative, so it's going in here. And in this case then, we're marking that in as 0.34 and 0.34. So my angles are going to be, so this one would be pi plus 0.34. This one would be 2 pi minus 0.34 would be the two positive ones. The negative ones then are going to be minus 0.34 and then minus, and that's going to be 0.34 shy of being minus pi. So I'll just write down what those 4 things are. Okay, so starting with the negative ones then, so this is going back this way, would be minus 0.34, and the other one, which was 0.34 shy of being minus pi, is going to be minus 0.280. The positive ones then, it's going to be all the way around from here, pi, and then plus 0.34, which is going to be 3.48. And the other one, which is 0.34 shy of 2 pi, is going to be 5.94. These are all in radians, and your last thing to do in this question is to divide these 4 by 2. And if you do that, you're going to get 0.17. You're going to get, sorry, minus 0.17 and minus 1.40. And you're going to get 1.74, and you're going to get 2.97. Right, just how we talk about the inverse trig notation, it is a wee bit strange looking. So sine to the minus 1 means the inverse of sine, so it does not mean 1 over sine, so it's a completely different thing. 1 over sine would be written as brackets sine x, close your brackets, to the minus 1, which is cosec, we know, because we know 1 over sine is the same as cosec. To avoid confusion, it's often written as arc sine, so that means the inverse of sine. So that's what sine to the minus 1 means. It means the inverse of sine. Likewise, you could have arc cos, and you could have arc tan. So they all mean arc sine is the inverse of sine, arc cos is the inverse of cos, arc tan is the inverse of tan. Okay, we're going to look at an important case here. And this is cot x is equal to 0. I don't think I can remember seeing this one come up in a long time, but cot x equals 0. And this is for 0 is equal to, 0 is less than or equal to x, which is less than or equal to 360. So in this one, you want to just think about y is equal to tan x. And we'll just think about the asymptotes. So tan x has asymptotes at 90 degrees and 270 degrees, i.e. when x is equal to 90 degrees or 270 degrees, tan x is effectively equal to infinity. Okay, so we have got cot x is equal to 1 over tan x. So 1 over infinity, this mathematics is not great, but it will do us to understand it. So 1 divided by infinity is effectively equal to 0. Therefore, cot x equals 0 when x is equal to 90 degrees or 270 degrees. Okay, and that's it. Right, we are now ready to do, it's topic 5. I think we're still on trig, part A, but we could do exercise 3, question 1, and also exercise 4 as well. So exercise 4 sort of talks about the inverse trig, but also go back to an example we did way earlier on there, where we had if cos x is equal to 7 over 25 and so on. So it just starts off a wee bit differently, but you have got enough information now between what we just talked about, the inverse thing, and also this. So I'll just do a wee quick example in a minute about that. But so to watch on with the video, if you want to see that, if you're good to go, that's fine. Okay, for those of you who needed the extra example then, it was given that a is equal to cos to minus 1 of 7 over 25, find sine a and tan a. So it's exact values, I think it would say in the question of these. So the solution of this is very easy. You're told a is equal to cos to the minus 1 of 7 over 25. That means cos a equals 7 over 25. Now the easiest way to do this is just to draw a right angle triangle, and you're really using your most basic form of trig, which is your SOHCAHTOA. So mark your angle A. Cos, remember, from SOHCAHTOA is cos is adjacent over hypotenuse, so 7 over 25. Now you may not realize it, but that's a nice Pythagorean triple. 25, 24, 7 always makes up a right angle triangle. So now you've got that. Then you can go on, you can find sine A, because sine is equal to opposite over hypotenuse, and your tan is equal to your opposite over adjacent, and that's it done. Okay, so very similar to the examples you'll see in topic 5, exercise 4, so they should be no problem to you.